Okay, so we're on TryHackMe and we're working through the First Shift CTF. This is part of the reworked SAL1 SOC pathway, and we're on to Task 5 Portal Drop. We've been given the logs to a CRM web portal and told that there's been a port scan and brute force attack on it, and we need to investigate suspicious file upload as well. And so these have been flagged in. We also have EDR access, so we can investigate the endpoint as well. But the first thing we need to do is investigate the log. So let me get rid of this and we'll get started. Okay. So we've been given the log file, and if we start to scroll through it, we can see user agents listed, Mozilla, PF API, okay, PF scanner, okay, so that jumps out at us. So looking at these scan requests, they're all coming from the one IP. Okay, so if we look at what our questions are, what is the IP address that initiated the brute force? So this is just scanning. They're actually specifically asking what the brute force was. So what I did with that is cat the access log and then grepped the login. So we can see here is an example login request. So if we look at it, the log without all the noise and only showing the login attempts, we can see primarily this is the IP that appears to be brute forcing, because 401, 401, 401, all these are failed logins. The other IPs 200 status, which in this instance would generally look like an approved login or an authorized login. So these 401s are what we're looking for, and when we look for brute force, then this is obviously it. There's about 20 different attempts there. So that's how we find the answer to our first question. And then how many successful and failed logins are seen in the logs? So as you can see, the log file is quite large. So we're not going to go through and count them, but we can use grep in the same way. So again, if we cat the access log, and pipe it through to grep post login. Oh, actually, I've already got cat in that command, my mistake, sorry. I've got it copied in another window. It will do a line count. So we're looking only for the login line in the log, and we're grepping only the 401, so the unsuccessful logins, and we're doing a line count. So it tells us there's been 35 unsuccessful logins, the 401. And then we do the same thing, but we can change the status code to 200. And it will show us that there was 18 successful logins. And so that's how we get the answer to our second question, 35 and 18. And we did that by doing line count on our grepped results. Okay. That was our third question, I'm sorry. What is the IP address that initiated the brute force? So we got that before when we were looking for the brute force. I forgot to highlight it, but that's the IP, so that was the answer. Following the brute force, which user agent was used for the file upload? So if we know that this is our attacker now, we can also narrow down the logs to only show his IP or their IP. I'll get rid of this window so we have. Okay, so what was the question we were looking at? The user agent. Okay, so the user agent data is there. That's the PF-scanner. So that's how we found it out. Looking at the logs of the IP. It's got the user agent there. What was the name of the suspicious file upload by their attacker? So we can see initially in the logs, this is all the login attempts that failed. Then there was a successful login attempt here with the 200 status. And once they've successfully logged in, they've then launched their attack. So they've gone to the portal and they've gone to upload. So we can see here, they've uploaded invoice.php. Okay, so the suspicious file uploaded by the attacker was invoice.php. At what time did the attacker first invoke the uploaded script? Okay, so they uploaded it. And then they accessed it. So it's there. The time that we're after. 6th of November 2025 at 2:27:34 seconds. And the formatting for that, you need to convert that log into the format that TryHackMe wanted. So it was year, month, date, space, time. Okay. What is the first decoded command that the attacker ran on the CRM? So we've got what looks like an encoded command right here. Whoops. Let me actually grab it. And we take that to CyberChef. And it looks like base 64. But once we've decoded it, it still looks like base 64. So it looks like it's double encoded. So we'd add another decode from base 64 in. So now I'll just show that again. So we decode it once, and it still looks like it's in base 64. So we decode it again, and we've got our output of who am I. So that's the answer to our next question. What is the first command that they ran? It was who am I. Based on their attacker's activity on the CRM, which Midas attack persistent sub-technique ID is most applicable? So I think this question is asked earlier because the next step is that we find out that their attacker has created a reverse shell. So that does answer what technique it is. It's ID T1505.003 persistence, and they're using the web server to create a web shell. So that's our answer for that question. Which process image execute attacker's commands received from the web? Now at this point, we don't need to investigate the logs anymore. We need to go into the EDR. And so in the EDR, we've got some alerts coming up. One of them is shell spawn and backdoor PHP. So if we investigate it, we have some information. the user that's running the web service is www-data. And if we go into process info, we can see here that this is what's spawning. So this is the answer to our question. Which process image executes attack commands received from the web? So it's /user/sbin/php-fpm 7.4. Okay, next question is, what command allowed the attacker to open a bash reverse shell? So with this, we could still use our log. I've closed it. Let me just get back to it. Before we decoded this command, the next command that they ran was this. So we could do the same thing and take that to CyberChef, and we know it's going to be double encoded. Oh, I did not paste it correctly. Oh man. Sorry, bear with me. I'll grab that again. Let's make sure I've actually got it in the buffer. Yeah, okay. Remember, double encoded, so it's decoded from base 64 2 times, and we've got the answer to the question. Bash -i pipe and dev tcp 15115 dot. Anyway, there's the answer. So they've opened up a reverse shell. Now we could also find that information in our endpoint here. So the other alert that we got was the shell spawn, and if we investigated this, we would see the command also there. So there's two ways you could have obtained that answer. Obviously it's easier just to come into the EDR and get the answer, but if you were investigating and trying to figure out the solution without access to this, you would just decode and you'd find it out. Okay, so what are we up to now? Who am I? The Midas command, the bash. Okay. Which Linux user executes the entered malicious commands? So we find that from the endpoint, and we know that the Apache server is running as www-data. So that's the answer to our question. So when they gain that reverse shell, they're going to have the user account of www-data. Which sensitive CRM configuration file did their attacker access? So again, we're going through our investigation. Unusual system behavior. So if we look into what's going on here, we can see that they've been looking for something. Oh, what system are we on? What's our IP? And find. Okay, so they're looking for anything that would have some information, and this is what they were after. So that's the answer to our question. They read etc try crm /config.json. Okay. What domain was used to exfil the database? And they then used curl to get it out, as we can see here. So the domain that they tried to access was portal drop 2025.xyz. So that's the answer to our last question. Okay, so just to go through them again here, you can actually see the formatting of the answers. What was the IP? We found that from the log. How many successful and failed logins are seen in the logs? We used grep to first check for successful. Was it, yeah, successful and failed? So first successful, so we looked for status 200, and then failed, we looked for status 401, and we just used line count to find out how many attempts there were. That was our answer. In the logs, looking at the IP address, we found that their user agent was Python requests. What is the name of the suspicious file? Again, in the log, we could see that they uploaded invoice.php. The first time they invoked the script, we saw that in the log as well. All we had to do was convert the time to year, month, date, time, which was the opposite of what they had in the log file. The command, we copied the string into CyberChef, and we double decoded base 64, which gave us who am I, which is also a very common first attack command to check what sort of access you've obtained, based on their attacker's activity. And this sort of followed on to what the next questions were. They did create a web shell further down. Based on creating the web shell, we determined that it would have been server software component web shell, which is persistence, which gives us the code of T1505.003. Which process? We found that from our ADR. Which command allowed the attacker? We could do that two ways. We either double decode the string from the log, or in our EDR, if we investigated, we found that out. Which Linux user executed it? In our EDR, we saw the user, www.data. What sensitive CRM configuration? We went through again in the EDR, we found that they cat this file, and then which domain was used, and then we noticed that they tried to use curl to output this file to this domain. And what flag did we get after competing all 12 EDR responses? Okay, and we got THM portal _ dropped. And on that note, we did have to solve the tickets. So this was, what was this one? A suspicious file write was detected in the application uploads directory. And then we had a couple of options we could choose from what to do. We wanted to quarantine the invoice.php file, which was what they uploaded, collect it, obviously, to find out how the exploit was utilized, and investigate it. And that gave us a solution for that. And then the they spawned a web shell using what was this one? This was the bash shell, wasn't it? Okay, yeah, they spawned the bash shell. So what did we do? We had to do two things. So we obviously wanted to block the IP that had done it and terminate that bash process. That was our answers there. Unusual system behavior. This was coming from www.data. So this was when they'd already got a shell, remote shell. So our options were to isolate the host, analyze what happened, how'd they get remote shell, and block or flag the domain and IP. So that gave us the solution for that one. And finally, there was a hands-on keyboard root activity, and so this one was an actual login, so we needed to contact the user behind the login to see if it was legitimate. If it was legitimate, we would have to close it as a false positive, and then some changes were made to the nginx config, so we also wanted to review what those changes were just to make sure. And once we completed those, we were given the flag of THM portal underscore dropped. Okay, so that's how we solved task 5, portal drop, on the First Shift CTF. Alright, I hope that helps anyone that got stuck on that one, and let's move on to the next one. Let's get it.